Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 310, longest increasing subsequence 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem. So, the first thing first is if you're wondering whether this is going to be on an interview, I would say probably not, to be honest. I think actually someone just pinged me on my Discord saying that this is a problem that's on binarysearch.com. I had actually solved it actually only a month ago, so it wasn't even that long ago, though I didn't remember it. And I would say that in that classification, it was a harder problem. Not just hard, it's a harder problem, right? So this is not gonna be on an interview, or at least like if it is, then just uh your interviewer hates you, and maybe that's okay that you don't get the job. So yeah. But that being said, let's think about this problem. So the reason why I say this is a hard problem is because it requires something called a segment tree. I'm not going to go over segment tree in this video because it's just a huge scope in problem. So it's just too much for me to go over, to be frank. But what I will do is tell you the ideas that are up to the segment tree problem. And here there's some, maybe not explicitly, but there is going to be dynamic programming and stuff like that, right? And I'm going to go over how that works out in terms of how to solve this with dynamic programming, kind of up to a point where you have to optimize a formula. Okay, so yeah. And the other thing is that, just as a thing about my timing, is that I actually did get this pretty much immediately, but it times out in Python. Though I think someone else did it in Python and it was okay, but I did it recursively with. Excuse me. I did the segment tree build recursively, where if you did it iteratively, I guess it's just fast enough because I was missing like the last few cases on TLE, and I just also made some silly mistakes because I was focused a little bit on the segment tree and not the problem itself, which because I'm still a little bit, to be frank, unpracticed, under practiced in segment trees. Anyway, enough segment tree talk. We're not gonna go over it. I'll show you my code later, so don't worry about that. But we'll talk about actually the explanation real quick. So okay. So yeah, ignoring the segment tree first. Oh geez. Okay. Let's get some whiteboarding first. No spoilers. Ha ha ha. But no. But the idea here is that, okay, let's say you have these numbers and the k is equal to 3, then the idea is going to be just let's say we write our DP solution, right? And here, this is a very hard problem in general, so I'm going to skip some of the basic parts of dynamic programming. Hope that's okay. You should be, like if you should learn things in a progression, and therefore practice. There are a lot of dynamic programming problems, so feel free to practice those as well. The first thing I would say to practice is the LIS, longest increasing subsequence, the n square version, if you are familiar with what I'm talking about. So in regular LIS, right, we can say that there's something like for I in range of n, and then for j in range from 0 to I, and then if this is actually the what I call longest path in the DAG implementation. Then if connected I and j are connected, then max of I is equal to max of I j plus 1 or something like this. Max of this is pseudocode and not real code, so don't whatever me. But and the connected part in this case, if you substitute it for LIS, it's just going to be like if num sub I is greater than num sub j or something like that, right? So that's like a very quick n square DP solution. Hopefully this makes sense. I'm not going to explain it that much, but I'm just saying that this is the basis of what you need, right? And then here, another place to do it is, rewording that a little bit, right? So this is a very basic dynamic programming, or very fundamental part of it. Is based on the values, right, from 0 to 10 to the 5th. So then here, using the same-ish idea is that we're for I don't know, say x in nums, right? Then here we want to instead of going for, okay, I mean you have the same idea, right? Is that for j in, you know, 0 to x, we go if connected dot dot dot, you know, all this other stuff, right? I'm not gonna write it out actually. So, you know, if connected stuff dot dot dot, update max, right? So the same thing here, really. Maybe I could copy and paste, but yeah. And here the if connected part is just if j is you know, x minus k, something like this, right? So yeah. And then the next optimization you may think, if once you have this, is just that yeah, I hope this part makes sense so far. I'm slowing down a little bit because I want to make sure that this part makes sense. But given that, you know, for example, if you're given the number 15, you're looking for number 12, 13, and 14, right? Or, yeah, 12, 13, and 14, and that's basically what this does, is update the max, right? So that's basically the idea, is this updating of max from certain thing, because 15 can only be added to 14 and 13 and 12, and then you greedily take the max of those three numbers to add 1 to, because that's the path that you're going to take previously, right? That's basically the idea. And of course you can do some minor optimizations here. Now notice this, because you could also count from, you know, x minus k, etc. You know, this is just a minor optimization, for example, so that you don't have to go from 0 to x minus k, for example, right? So that's one thing, and that's pretty much it, really, to be honest. Here, what's the complexity, right? Well, x can be from 0 to n, and k can also be 0 to n. So this is still going to be, in the worst case, n square, because that's just how, you know, the for loops will end up, right? And why is that? Because this loop is O of 1. Will take O of 1 time, but this loop will take O of k time, right? So this is n squared, where k can go to n. So you could also maybe say n times k. Maybe that's a little bit more strict on the timing, right? Okay, so then now, and this is the part where we make the jump to segment tree, to be frank, is that yeah, so that's the part where you make the segment tree, and a lot of this is just knowing what segment tree does, because you look at this structure that we have here, and we go, okay, which part can we optimize, right? Well, we can't really optimize this, just because we have to look at every number, at least the way that we and in order, because that's the way that, you know, these sequences work. And yeah, so they have to figure out this one. And then the idea here is that, okay, what if we have a range query where we get the max, you know, essentially we're taking the max number in this range, right? And then you ask yourself, that's how I did it, I'm just explaining that part. I'm saying, okay, now I take the k, you know, I look at the last k elements from, because we're writing it another way, is get the max of, you know, max of minus k dot 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 max of x minus 1, right? Something like that. And basically the idea of a segment tree is that, okay, now we have this in a query, right? If we can reduce this, and we can with segment tree, to O of log of some u for universe, then, you know, hoping that this is a little bit faster. And that's pretty much it, really. That's the idea, is that now you can enter this in log u time by having the magic of segment tree, like I said. And if you're able to get to this far, I would say that's probably good enough for an interview. Like on a level where you're ready for an interview is what I mean. It's just that, you know, like if you didn't know segment tree, there's no really no way to solve it, and you know that's pretty much it, right? Like, and you're not going to come up with segment tree, to be frank. um you know, it's a very research thing. So yeah. And with that said, now I'm gonna go over my code, but this is the idea. Hopefully this is good enough for you to you know, just look up research segment tree, and you could even plug in segment tree really, and it'll be working for the most part. Leetcode is a little silly, like I said, with the timeouts, and we're gonna go over that in a second. I guess I'll just leave it up here for the case. This is my segment tree implementation. I'm showing you, but it's gonna be too slow. Like I said, I think I've seen ones where if you don't do it recursively, it'll be fast enough. But I did this recursively, and so it is too slow, too sad, too many functions. Yeah. So this is my seg tree code, and if it means, yeah, let me scroll down a little bit as well so you can see the second half. And if it means nothing to you, then like I said, you have to understand it, and that's beyond the scope of this video. But that's just segment tree stuff. Yeah, maybe one day I'll do another video on it. But yeah, and this is my actual code. Like, this is a lot of what we said. Maybe I could actually clean this up a little bit. But yeah, first we get the max of all the numbers. This is just to set up the segment tree. We set up best as a default, and then now for each number we go, okay, the current best is 1, and if so, basically this is just to make the variable names a little bit easier. But basically now we query, okay, what is the max from range of c minus k to c minus 1? This is exactly what we said, except for we used the letter x. But yeah, from x minus k to x minus 1, we get the maximum value, and then we add 1 to it because, well, that's to add, you know, the current number to it. We get the max, or we, you know, update best if necessary, and then we update the current best. And c best is basically the best, the longest subsequence that ends with the number c. That's basically like the dynamic programming way of looking at it, and then we update it back into the dynamic programming array using the segment tree as the dynamic programming array that you may have seen. So here we get the range max, and here we do the update, and then we return best, and then there we go. Like I said, this part is going to be O of n just because it is. And the max part and the update part will be O of log u. And when I say u, I mean that u is the size of the universe, which in this case is just going to be 10 to the 5th, because every number is going to be smaller than 10 to the 5th. So yeah, so yeah, and this is going to be O of n log u space time in total, and O of u space for the segment tree. Cool. That's pretty much all I have for this one. This is my Python code. I'm just going. So this doesn't. I made 2 silly mistakes on base cases. You can look at it on the video. So it's not. It's just very silly because I was focused on the segment tree that I like. Basically, I forgot this, or I didn't do this statement, so there was running into issues, and I forgot to update this one later or something like that. You can take a look. It's not a big deal. But yeah. But now you could pause and kind of look at it. But I'm going to show you my C++ code just for completionist. So this is the code that AC'd for me. It can accept it. Yeah. But all of it is just really copy and paste from my Python code, except for into a different language. So yeah, this is my tree. This is my max code, my update code, and we don't need to build it. And this is the code that is very similar to the logic, right? Like I said, we just take the range max from c minus k and c minus 1, and then that's it. And then we take the max of that, and yeah. That's all I have for this one. Let me know what you think. I think conceptually, honestly, this is very gettable, minus the segment tree. If you didn't know, like I said, if you didn't know segment tree, there's almost no way, or I wouldn't expect anyone to get it. So yeah, that's it. that's what I have. So let me know what you think. Stay good. Stay healthy to good mental health. You could watch me self live during the contest way awkwardly now. Okay, I wasn't sure about proving that one, to be honest. Alright. Longest subsequence at most k. Okay, what's n? N is 10 to the 5th. So maybe some variation of the binary search one. Right. K is 10 to the 5th too, so it's so it's the what do we call it? Don't tell me a segment tree. This tree. Yeah, I think it's segment tree, right? Because then you just want, for a number, you want the last k numbers and then you want to max up that. Okay, fine. I'm just trying to find my segment tree template. That's one of the things I do have a template for. I don't know if it's fast enough though, to be honest, but it should be okay. Okay. Let's copy and paste. Is this the one? No, this is max. Yeah, I think max is the one we want, actually. I have to think about the function. Hopefully this is right, otherwise it's a little bit awkward, to be honest. But basically, we have okay, so seg tree is equal to what is n and m within this again? I don't even remember, to be honest. Oh, m is just the initial. What is n? N is well 10 to the 5th. So what's the number of elements? Is just up to 10 to the 5th. Okay, so okay, and then now we have for c as a nums. We want to get I don't use seg tree enough to remember stuff. It's been a while. I might get the ideas, but so okay. So for c, we want the max of there's no 0, right? Nope. From 1 to no, we don't necessarily want it from 1. Let me look. I should write my notes on these things, because I think we're mostly right, but I just don't remember how to do it. Because I don't do it enough. This is like a very specific syntax, right? But this is a little bit, if this is the case, then this is a very silly problem anyway, so just taking my time, try to find, how do I call this again? Update. Okay, whatever. This is from 1 to, is that right? But and then the one that we actually want to focus on is, I always forget which one is the TL and TR. That's why I'm a little bit sad. Yeah, I think this is right though. And then the left right is gonna be C minus K. Yeah, and C minus 1, I think, right? So yeah, best is equal to this, and then yeah, and then we update. Okay, well, C best say, so best is equal to 0. St dot update. We want to update. What are we updating? We're updating C because then now it's C best. Okay. I imagine some like people who are better than me at sec tree probably got it very quickly, but assuming I got it right. Was this 541? Okay. Huh? Memory limit exceeded. Huh? Did I do this wrong? For shouldn't get memory. Shouldn't be memory limit exceeded of all things, unless I Alright, let's see. Really? I have a typo in some places or something? Well, debugging this live is not very fun, but I'm probably building it in a weird way, but what? This should be just wrong, but maybe it is. It's either that or I'm doing some recursion thing. Why would this memory limit exceed? What am I doing wrong? Dun dun dun. Because n is just, what is max? Yeah, this should be 15, right? What am I doing? Let's see what happens here. Okay, that's good. That's what I expect. How am I getting memory limit exceeded? Maybe I do have. Maybe my parameter on it is on the other stuff is wrong. Yeah. Okay. So 1 and max. Did I get this wrong? Precision. Let's see. Okay, so that means the max as well. Let's see. Maybe I thought this is the this could be negative, couldn't it? That's maybe why. Let's see. This is equal to 1. Silly mistake if that's the case, but that's okay. I forgot about that. Okay. I mean, at least it doesn't max out, but and we need this +1. I think that's the part that I forgot, which is why it's returning 0. So that I get 5 for the first one. Silly mistake, but that's okay. I'm still learning on the segment tree. It doesn't really come up that much for me. Let's give it a submit. Hopefully it doesn't time out. I should try the case with 10 to the 5th. That's the only thing that may be a little bit like TLE, maybe memory limit exceeded or something like that. This is taking a long time, so maybe there's a that's maybe not what I expected. Oh wait. Oh. It's because it's matching the 1 and the 1, and I'm being a little silly on because I was just a little bit lazy here. So what happens? And then this should be C minus 1, but then Okay, so I basically, if c minus 1 is greater than 1, I guess we do this. Yeah. That's a little sad. Silly mistake. Okay, fine. Or, I mean, I think I was just too focused on, and this is gonna be another sad one maybe. But I think I was too focused on the sec tree part that I forgot to think really about what the answer should be. Stuff like this. I thought I did this here though. That's why I did. Oh man, I was C best is equal to 1, but I didn't do this part. I am just being very sloppy right now because like I said, I'm focusing on the sec tree part and not the problem part because I'm a noob in it. And that's sometimes that happens. Is that you? I guess I should win it first. Is yeah, I'm making a lot of silly mistakes though. But like I said, I'm focusing on. Okay, so this part I kind of more expected, but but now I'm trying to figure out, well, what does that mean? Is it a, I mean, 613, but I think it's just that it is too big. But the idea is still right. Can I do this in a better way? Because then basically you're minimizing the. It's DP where you look at the K elements. Wait, it sucks that it cost me 2 wrong answers for. I mean, this one's fine, but the other 2 is a little bit sad. Is there still maybe there's a dumber way that I'm just being too smart about. Basically, you just keeping max. Well, it's always incrementing. So you want to take a max between the 2 things, and this is the way to do it for that for. Yeah, I don't know that there's a easy way to do it another way. How does it look? Wow, everyone's got it done already. Is there a sillier way? Maybe I'm missing the more obvious way. Let me think. I mean, this is right, but it's too slow. 10 to the 5th. It's. But that's the silly thing is that, like, it probably is fast enough for every individual case, but does it tell me? Oh, jeez. I lost a case. 82 of 86. So we're close. I don't know that if I do C++ is fast enough. Do I have template code for C++? I don't even know. Might have to rewrite this in C++. Let's see. Didn't think I would. Oh my. Oh my. Alright, let's try another language then. Okay, so this is the actual code per se, though I should not have made 2 mistakes on it. I was just kind of, yeah, I was just kind of silly. My timing is a little tight, actually. But, yeah, okay. This is so annoying to set up. I don't know how. Yeah, that should be fine. Something like that, right? Maybe I didn't need this point. Would it be faster? Let me take a look actually back in Bible. What if I don't need to build? So it went from 5 seconds to. It's a little bit faster, but not that much faster, I guess. Not enough. I don't even know if this. That's the problem with switching languages. I don't know if that's fast enough. The recurrence is right, unless I'm missing something obvious. Well, I mean, unless there's an easier one. But. Trying to think whether there's an alternate way that I'm just missing. I don't know. Like, is there a way to do with sorted list or something? I don't know. I don't think so. But my time constraint wasn't so tight. I would been okay, but. I'm trying to see whether it's people pinging me to be awake, but I'm awake. My friends think I'm sleeping in, but I'm sticking up to do Leetcode. So okay, let's copy this. How do I do it again? Let's see. Is this right? I don't remember anymore. I'm not gonna lie, I'm just looking through my old I don't remember the syntax. Okay, no, this is right, I think. Where's this auto intention thing? Okay, fine. Looks like I've just copy and paste this. Sorry friends, I'm just literally transcribing. I'm not really doing anything that interesting. Just rewriting this really. Just gonna do this. That's the thing, is that I don't actually even know if this. Maybe there's another more obvious way about it, but the other thing is that I'm kind of uncomfortable right now because I was doing it in bed and I was hoping this would be a quick one, but it is what it is. I guess update doesn't actually return anything I lied. Did I not miss the type? I have an extra paren for some reason. Is my computer slow or void function up? Oh, okay. Wait, what was my code then? Wait, what was my code before? Let's see. Oh, this is not an update. Okay. That's not a return. I thought that was weird, but I just want to double check. Oh, wait, this is. Okay, that was much faster actually, so let's give it a submit. Like I said, I'm still a little bit need to practice. Okay, that's just silly that I needed to do it that way, but so I was just needed to practice on the seg tree, so that's why I kind of lost my focus on the easy part, quote unquote, and got two wrong answers, but otherwise I did pretty okay. I spent 12 minutes rewriting it, so I'm gonna lie and say that I did it 12 minutes quicker, but otherwise, yeah. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. I'll see you later, and hopefully next time I'll see you soon. Bye bye.